This is a continuity. I've did the question 1 until question 1.5, then I had some problem. I had a technical error. So if you want question 1 until question 1.5, you can join there on my YouTube channel. You'll see it. So let us attack question 1.2. Question 1.2, we're given there a rectangle having sides, as you can see, y minus 3 meter and x plus 2 meter has a perimeter of 24 and the area of 32 square meter. Calculate the value of x and y. You know your rectangle, isn't it? The perimeter of the rectangle. So without wasting of the time, so far everyone knows the rectangle, obviously. So you know that the perimeter, grade 12, you know that is 2 base plus 2 height, isn't it? So then we've given the perimeter. The perimeter there, it was what is 24 base 2. Then what is the base there? If you can check the can say it's up to you. Usually say it is one and the same thing. Can say x plus 2 here, plus, then say height it's y minus 3. It's up to you. We have given these sides there. Right now it's a matter of math now. Well, we have here 24 is equals to, it distribute, I'll have 2x plus 4, then there will have plus 2y minus 6. Yes, so minus 6. So this is what I have there. Since I have this, I can make what x the subject if I want. Okay, make subject. Here these are like terms, as you can see, these two. When you subtract, you have negative 2, then you transport to the side, this will add. When you get this side, will be 26 equals to, we have 2x plus 2y. Then if you take here, we'll have 26 minus 20. Let me make x the subject. If I make x, this will be 2y, or you can take out the common factor and multiply. It's up to you, but it's one and the same thing. You have 2y like this. So we'll have 2x there. Then you can divide by 2 both sides. 26 divided by 2, we know that is 13. Minus 2 divided by 2 will be 1, which will be y. This and this will cancel. We'll have x to be this. This is equation 1. Now we can go to area. We know that the area is base multiplied by height. Then we have our base. We can say our base is x plus 2. Then we can say the height is y minus 3. As you've given, then what is area? It was 32. We've given the area to be 32. Then here we have 32. All right. But funny thing here, we have that x to be equals to this, right? Okay, can say this equation 2 either way, or then you can say tell the examiner substitute equation 1 into 2. Then you can put that there. So the examiner will see, we'll have 32. Then when you substitute there, we'll have 13 minus what, y plus 2 into y minus 3 there. Definitely this is 32. When you add this, you'll have 15 minus y, like that, y minus this. This is what we have. But if you can distribute there, if you distribute, okay, this side, we still on our left hand side, we still have 32. Then if you distribute, you have 15y there. 15 multiplied by that will be minus 45. If I'm not mistaken, multiply that will be, okay, minus y squared. Then them will be, if I'm not mistaken, minus 3y. This is what I will have. Then I will write this in the standard form. I can take all of this thing there to the other side. So I will have y squared, supposed to get, I will have minus 18y plus 77 equals to 0. Then it's a matter of factorizing here. We have to find two. We have 77. Two numbers that we multiply will give us 77. When we add, will give us minus 18 them. So we must be, let's check. 7 minus 7 multiplied by 11 will be 70. That thing, I don't know the factors there. If you can say 7 multiplied by 11, what I will get 77. But when I add, if you add minus 7 plus 11, you'll get what? Okay, minus 18. You'll get minus 18. So okay, these are right. As you can see, so that means they will have those factors there. We'll have those values, which two numbers will have minus 7, as you have seen, and it will be minus 7. We say minus 7 multiplied by 11. Okay, that must be negative. Okay, this must be negative, guys. Then it will give us 7. When I add, yeah, must be negative 11. It's fine. If I say negative 11 like this will be equals to 0. Therefore, you can see y is equal to 7 or y is equal to 11 is equals to 11, right? This is what we have. But now let us check about let us return back to here to this guy here and find our axis. Here is this guy. Remember, we've made this guy the subject. We can find the x values by substituting 7. If you substitute 13 minus 7, also you can use the 13 minus 11. What will be x? Find those values there. X will be, okay, this will be x will be equal 13 minus that is what is 6, or what? Yeah, 6. Then, or also here, okay, actually not, it must be again the value 13 minus that is 2. 13 minus 11 is 2. So yeah, you're supposed to get what I'm doing there. Supposed to get these values, guys. If yeah, this is what it is. So yeah, this is what it is. I want us to check. Okay, we have 1.3 again. 1.3 says show that, given that, you can see 1 plus x. I know this is not clearly, but this is like 1 plus x raised to the power of m, like this, plus x raised to the power of minus m there, and then you square this guy there, you minus, we have y minus x, then you have m there, x, then minus m there, you square. Also this is m, this is m, those are m's, but here is negative, also here is negative. So they want this, they say they want us to, okay, they say show that, okay, all of that we've given that expression. Actually, this is a difference of 2. So let me check. We have plus, this thing is the same, but you see that you have minus. Actually, this thing is a difference of 2 squares. That is a difference of, according to my analyzing of mathematics, that thing is a difference of 2 squares. As you can see, we have squared there, we have a negatives there. You see, this is a difference of 2 squares. Actually, that, okay, it's fine. But so this is divisible by 2 for all real values of m and n. How can you attack this, guys? How the value to be, it is all the, according to me, I don't know, but according to me, even number, for me to have a divisible, I think about even number. Odd numbers cannot, I know all numbers can never be divisible by what? by 2, but even any even number, doesn't matter which one, any number, or the even number, if you divide by 2, obviously will be divisible by 2, any even number. So it's what I have, it's what I know for now. But this, I know this is simply just a difference of two squares. I can quickly erase this, or I can drop that and make can erase this. So it's fine, let us have that. So when they say we should show this, okay guys, actually here we have this, guys, 1 plus x raised to the power of m plus x minus m, like that. Then you have square there, minus 1 minus x m minus x minus m, there you have squared. This for me is a difference of two squares. Is this format, guys, a difference of two squares? Let's say you have given because we have x, I will say x and y, but okay fine, let me say a and b for argument's sake. Then I say squared. This we know, if you are, you know this, what will be equal, this is simply, or actually, oh no, that you, so this is, that is a perfect square. I don't want to say perfect square, I'm trying to say if you have given a squared minus b squared, like this, that was a perfect square. So if you factorize this, we know this is a difference of two squares. If you factorize this, will give us this, isn't it? So we have this. So guys, it's the one and the same thing. I can, to make my life easier, I can make this a to be equal to these guys and make b to equal to that. It's like a k substitution method. I can let what to be equal to this. I can let, okay, example, I can let a to be equals to this guy, the one that is inside that bracket. I can say 1 plus x m x raised to the power of m. We have also plus x raised to the minus m, like that. You see, I equate that what is inside there. I can also let b to be equal to the, to become this. Now the other one can let, okay, we know that b, I can say b to be equals to the other one, whereby the other one is, what is that, 1. Now we have minus x raised to the power of m minus x raised to the power of minus m, like this. So then I can use now, I have this now. Remember, I can take step by step, I can insert that. Now remember, I have that brackets. What about if I can say, what about a minus b? I want you to understand this. We can do it straightforward, but I make, for the sake for you guys to understand, I'll do this. Remember, you said a is this, a is like, is that, all of this. So if I take this a will correspond with that a, this will be equals to that. Okay, we have, remember that we have that a there, isn't it? So okay, there we have that bracket. A, I will replace with 1 plus x raised to the power of m plus x raised to the minus m, like that. You understand? Like this, right? Then we have this minus here, guys. We have that minus. We have that minus. We have that minus. But because, remember, this is terms, these are three terms, because you cannot just, because you cannot just say minus, you're supposed to put brackets because you have more than two terms. So I can insert my bracket, like, or parentheses, for argument's sake. Then I can say minus, like this, minus there. Then what is b? What is b there? We know, guys, here it's our b will correspond with this. You can take b, there is b. If I can say b will be 1 minus x raised to the power of m minus x minus raised to the power of minus m, then like that. So if you take this distribute, check. This and this will be minus 1. You'll cancel with this if you know math. Okay, let me just write it so that you'll see 1 plus x x raised to the power of m plus x minus m, like that. We distribute, they will have minus 1. We distribute, and as you can see, we have plus x raised to the power of m. We distribute the negative, as you can check there, will be plus again x raised to the power of minus m. Now the minus 1 and this 1 will cancel, will simply fade away like that. So we still have this, our equal sign here. Now we'll have guys, check this, I like them, check, plus this guy. Also we add up that guy. If you can check this, we have this guy and this guy, they are the same, guys. So you simply is equal to 2x, you'll see m there, those guys, they are the same, plus again the other guys, they are the same, as you can see, minus m. So we have this, but this 2p is equals to what? A minus b. Remember, we have taken. Now we're left with, we have this. Now we have done with this part, guys, but there's a difference of two squares. We must also deal with other part that has a positive. So if you deal with other part, the other part here will have a, right, plus b, you see. Then you know that a, we set a to be equal to that, a is 1 plus m, right, like that, as you can see. Then this will be 1, guys, 1 plus x m, right. If here we remember, we set m to become 2, we have let that to be equals to this. Remember, this is minus that. You put your parentheses like this, or you could call it bracket, but say plus, but I know there's no need because of the, but let us just put it, there's no problem. But what about the b? Remember, we said b, we let it be to be equal to this guy there, or I can simply grab this guy, can copy that guy, like let me just copy that guy like that. Then let me just paste it here, this guy. Then boom, here it is. Boom, we have this there. How cool is this? But now you know, if you distribute the positive, will never change anything. They will have 1 plus x m. We have m there, plus x minus m, like that. Distribute that, would be plus 1, would be minus x m, will be minus again x minus m. So guys, check, this and this will cancel with that and that. You see what will happen again. If you can check again there, this and this is minus, will cancel with that because they are the same, but these two will add. We'll simply have, this will be simply equals to 2, as you can see. This will be simply equals to 2. That means a plus b is equals to what? 2. So we know our difference of two squares now, guys. Remember the aim. Don't know, guys. Remember, the aim is to find this. Do not forget about the visible. Now we can make this. We have set this to be this, isn't it? Remember, we know that. Remember, our difference here is our standard, but we've calculated everything, isn't it? So if you can check a minus b, we have a minus b here, it's a minus b there, we have a minus b here, it's a, we have there, can come there, a minus b is this. You plug like that, but we must also have a plus b. We've just calculated a plus b is 2. We have it there, which is 2. Then you multiply this by 2, by 2, by 2. Here we're supposed to put 2. Remember, all these things, they're supposed to become 2. Here it's supposed to be 2 also. Here, remember, they are 2. Here they're supposed to be 2. There, I don't know where it went, but must be 2. Remember, from remember this thing, and they are the same. When you add this and that, you'll have 2xm. When you add this and that, you'll have plus 2x minus m, like this. So which is a minus b, which is a minus b. So as you can check, guys, if you distribute this, you simply have 4, right? xm, for argument's sake, so I can take out, okay, let me take out 4 as a common factor for argument's sake. To explain this, plus I will left with this 4. 4, it's a 4, we can explain 4, it's an even number. 4 is even. If you multiply, you must know, guys, if I multiply even, let's say even number multiplied by odd number, will always, no matter what you do, will always give us the product. That's what our output will be, even. Will be even. And then even is divisible by what? Is divisible by what? By that 2. Is divisible by 2. Divisible by 2. Even. So do you see here, guys, whether you, doesn't matter whether you, well, we don't care whether the number of m or of x is what, but as long 4 it's an even. For argument's sake, 4 multiplied by, let's say there you get your value, let's say you get 3. If you multiply 4 by 3, you'll get 12, whereby 12 it's an even number, will be divisible by 2. Any number that you'll put, when you multiply an even with an odd, you'll always result as an even. And an even number, it is divisible by what? By that. And so you can tell, and you can tell the examiner, you can write like this. If you can, you can even show, like, you can demonstrate like this even to the examiner if you want. Then you can say, you can even show them like this. You can say, therefore, for this thing, for x like this, what we have there, our result minus will always, this will always, I can say will, can, this is a, this will always, you can say, maybe you can say always, will always equals to even. And then 4, and then 4, then you can say, therefore, for any value of they said, what did they ask? For any value of x and m, isn't it? They say for any value of m and n there, which is n, or this thing, it's n, thought it was m, guys, but it's one in the same. For the value of m, n, x, m, guys, but you see what is going on there. This is n. I don't see that. I don't see it clearly, guys. I don't, but it's one in the same thing, guys. In case you can see, there we have m. You can only adjust, but it's a one in the same method. You can put n like that. Nothing. There's nothing like can put n. I did not realize, but as you can see, there's nothing will change there. You'll simply have this. So there's nothing fancy that will change. Even for any value of n, we still continue for any value of n, and for m and m will always be equals to what? Even. For any value of that, will always equals to what? Will always equals to even. We have proven this. will always equals to what? Will equals to even. And then every even number is divisible by what? By 2. So yeah, this is what it is, guys. Yeah, we can explain like this to examine. You will surely understand. So this is how you go about. You can write this is one in the same thing, guys. Do not worry about this I did not see, but it's a one in the same thing, guys. There is no problem there. This is one in the same thing. So thank you guys for watching. Thank you guys for watching. Thank you guys for watching. And please do not forget to subscribe to my YouTube channel if you have found this helpful.